Today we're talking about every LCA person's favorite topic, which is baselining. I know it's something that both Laura and Rachelle are very passionate about, as well as myself. Um, Quick primer. So my name is Luke Lombardi. If I don't know you, um, uh, all three of us are part of the CLF-LA hub. Been putting on events for we're 5 years in our sixth year now as a hub. I work at Bro Happold, co-chair at the SC2050 program. Laura, Rochelle, do you want to introduce yourselves as well?
I'll go for it. Yeah, I work for Carbon Leadership Forum HQ. This is one of the hubs of CLF. I used to be a structural engineer.
Laura, I work for Walter P. Moore. I actually am an architect, not a structural engineer like many of my colleagues. I co-chair the Walter P. Moore Sustainable Design Community of Practice, and I work both in the enclosure team and also doing sustainability, doing LCAs, and kind of supporting our embodied carbon reduction initiatives.
Great, thanks. And so today, so this is a presentation that we gave at a conference, the Net Zero conference in Los Angeles, almost 2 years ago now. I think it was mid of the year 2024. But today we thought we'd bring it back because I think there's still a lot of great content. We're gonna touch on a couple quick updates, and just why we're talking about this again, and then go through the whole building LCA pathway, quick primer on for CALGreen, which was kind of the original impetus of this presentation. Laura's going to share sort of the thesis of our presentation of comparing baselines, and then Rochelle and myself will share some examples, practical considerations. And again, hopefully we have some time for good time for discussion because I think it's really important that LCA practitioners, and we're excited to present, talk to this group with CLF, because why we're doing this again, a couple years ago, we sort of thought that maybe we'd end up in a place with benchmarking where we'd have something sort of similar to EUIs on the operational carbon side of things. And it seems like the direction we're heading today with things like LEAD v5 and as well as like some other policy, both established policies with CalGreen in California, as well as emerging policies in other places of the country, that this percent reduction is still going to be an important piece for embodied carbon reductions moving forward. So we should probably continue to refine and hone in on our process for measuring that percent reduction. So we're bringing back the presentation. Also just great to get it out and kind of share this framework. I think at some point we had aspirations to write a white paper, and at the close, I think plug the CLF, I think is going to start a working group, but generally good content and want to share. So there have been some updates since we originally gave this last year. CLF published their benchmarking V2, which does set some targets or sets a framework for different percentiles of performance based on just under 300 buildings that were studied. But as you can see, just pulled out a snapshot, plug for the Explorer tool that Mel pulled together from the hub. That is a really great resource. But if we just look at something like tool, there's some pretty significant discrepancy, even just depending on what tool you're using. So still reasons, as well as having different project typologies, unique projects. Like there's no benchmark for like a stadium project, for example. So just more reasons why this percent relative reduction is still going to be important. Very quick primer on CalGreen, especially since this audience is now a little bit broader than just Southern California. But as of 2024, California did pass the first statewide embodied carbon policy. It covers non-residential construction. It's not the threshold is larger than 50,000 square feet. Some important exclusions here, including like hospitals and that sort of thing. There are three pathways to compliance. This presentation is going to talk just about the life cycle assessment pathway. And we do have lots of other resources. We have a whole webinar series that we did with CEOC and A.I.A. as well as some online resources. We can share a link to this as well. But the thesis of this was it's really important as a community that we be sort of policing ourselves and what is standard practice for setting a baseline. I snagged this cartoon, which I kind of like of, we want to make sure that, we aren't putting out practices that are cutting corners or finding, not providing best practices. Something we continue to see every now and again is this like a CALGreen baseline that conflates the prescriptive path that has a very high threshold for performance EPDs with a baseline, which is not the case. So we're going to highlight some of those things. I think this audience is pretty well attuned to how to conduct an LCA. CALGreen provides us a framework. We know what the physical scope is. We have a set of tools that we can use, and we're measuring the results against strategies that we implement and incorporating those into the worksheet that's required by code. But what is that relative, what's that relative reduction from? So this is where I'll hand it off to Laura.
Great. Thanks, Luke. So the 10% reduction, as we all know, is from a baseline, and kind of the purpose of this presentation and what we hope to have a discussion with you all about after the presentation is like, what does that mean? What is a good baseline? How are we making sure that we are truly getting reductions from business as usual? So one of the resources that we relied on for this is it has a very long name, the SEI WBLCA Reference Building Structure and Strategies, and it has a couple of useful definitions in there that we're going to lean on for this. So it defines a baseline as a design that exhibits industry standard materials and practices for a building that meets the functional requirements of the project. So there's kind of two important aspects to that we've highlighted here. And then how is your design different than the baseline? Your proposed design should demonstrate that it intentionally deviates from those industry standard materials and practices. And you have to be able to show that this is what you actually built. That's important, right? Because if you incorporated some really great embodied carbon reductions into your design, but the building didn't get built that way, then you haven't really made a change. Okay, so functional equivalence. I'm sure probably a lot of people on this call are familiar with this. That is really important because if you are comparing apples to oranges, then maybe you're not getting a true embodied carbon reduction. So that reference building structure and strategies document that we talked about defines it as a condition that occurs when the baseline or reference building and the proposed building meet the same functional and or technical requirements. So it's fairly open because there are lots of different things that we can do to optimize. So if we keep that baseline definition too tight, we might be not allowing ourselves to actually account for those reductions in the LCA. CALGreen has a slightly different definition. It's defined as a building of similar size, function, complexity, type of construction, material specification, location, and that it must meet the energy code. So you cannot have a baseline that does not meet the energy code. The other piece of this is industry standard materials and practices. So when you're thinking about this, what kind of materials, what kind of structural systems, what kind of enclosure systems would be considered industry standard for your project's type and location, and what did you do differently from standard? So if you are building a residential apartment building, say, even though that's maybe not the primary type we're looking at with CALGreen, and those are typically made of wood, you're not going to use an all concrete building as your baseline. That is not kind of industry standard for your project's type and location. Now let's get into some optimization strategies that we might be considering. And these are not the only optimization strategies, but we've kind of put them into some buckets for the purposes of this discussion. So you might want to look at design efficiency, so reducing the quantity of materials you need to provide the same function, limiting the use of materials that are high in embodied carbon, selecting alternative assemblies that use less material, and eliminating inefficient conditions. Alternative material selection is another strategy. So replacing carbon intensive materials with lower carbon materials or alternative system selection. procurement of low carbon materials, so you're buying better than industry average products within a material category. And the final one is building reuse. So I know there's a separate reuse pathway in CALGreen if you are below the pathway for the threshold for the reuse pathway, but you're still doing some use of salvage materials or some partial building reuse. That is a good optimization strategy to reduce embodied carbon over building a completely new building. So creating a baseline, again, that reference document that we're talking about kind of proposes three ways of establishing a baseline. One is comparing to an existing building. CalGreen requires the baseline to be project specific, so this is not an option that we can use in a CalGreen LCA, but the other two are pretty relevant to what we're talking about. Those are the building archetype and the early design. So the building archetype is kind of a design that represents typical construction for your project type and location. And you might want to use this if you are choosing alternative systems. For example, if you're doing like a mass timber building, but typical construction for a project of that type where you are is concrete or steel. So that's when you might want to use the archetype approach. The early design approach is sort of an earlier version of your design before you optimized it. So this is appropriate when you've kind of optimized for reduced material use or you've procured low carbon materials. What we don't want to include in this early design is including kind of material reductions that come from design refinement in the baseline. So like if you have some really rough estimates of how much material you're going to use in SD and you kind of refined your understanding of how much material will be needed in DD or CD, like you don't get to take that as a reduction. It's just for kind of true optimizations. So if we come to the next slide and we look back at those strategies that we were talking about, there are different baseline approaches that kind of lend themselves to these different strategies. So if you're looking at design efficiency, you might use either of those. If you're looking at alternative material selection, like the example that I gave earlier, like you're doing mass timber, you're probably going to want to choose the building archetype approach. If you're looking at procurement of low carbon materials, you would use kind of your same, and that's the only strategy you're using, you might use your same kind of building design with baseline versus actually procured materials. And then the reuse, you'd probably also want the building archetype approach. So what's in your LCA model? Because these are kind of the three attributes that are going to change or maybe not change between your baseline model and your as designed model. Your materials, what's your building made of, quantities, how much of each of those materials did you use, and then the environmental impact data that's associated with those materials, thinking about how and where those materials were made, and how they compare to the industry average. So in our baseline, we have standard materials, we have typical quantities, and we have industry average environmental impact data. And in our optimized model, we might have alternative materials and or we might have reduced quantities and or we might have product specific environmental impact data if we procured low embodied carbon products. I'm not going to go through everything on this table, but we've kind of put these into some categories, looking at those different strategies and looking at which of those attributes of your model you're going to change. So Luke, if you want to click to the next one, I think some of them will highlight. So for example, in the procurement of low carbon materials strategy, your materials and your quantities are probably going to be the same between your baseline and your optimized, but the impact data, you'll be comparing a product specific low carbon material that you've procured to the industry average. You want to click again. And then for the design efficiency example is that your quantities are going to change, but maybe your materials and your impact data may not change. And you can kind of use any combination of these different strategies. But I think we wanted to kind of pull this out to think about which strategy you're addressing and what kind of baseline approach you might use. And again, you can combine these in all kinds of different ways. Let's go to the next one.
And I might add, some of this might not be exactly like novel, I think, but having a framework that we can agree on and kind of be concise or consistent amongst each other, I think is important. So I really love this table. I think it's a nice, simple way that captures most of what we do as LCA folk.
Okay, and then thinking about material baselines, and this slide is a little bit old because there's a new CLF baseline report, but it's really easy to find those material baselines through the CLF report, industry average EPDs, benchmarking studies, and the kind of average data that is found in whatever LCA tool that you're using. Next slide.
Wait, sorry. I just want to add also for the CLF baselines report. I think if you guys aren't super familiar with it, I would definitely check it out because the latest one from 2025 includes a lot of new product categories that weren't previously included in 2023. So there's a lot more things that you can compare to now.
And then one of the other things that we always like to reinforce with folks, especially people who are newer to LCA, is that your material reduction should be taken from the industry average, not from the worst possible material you could have procured, or not from like those CALGreen prescriptive pathway references, which are higher than the industry average. If we want to document a true reduction from business as usual, we have to start with business as usual as our baseline. And I'm sure everybody on this call already knows this, but as you're working with newer folks who are new to the LCA world, this is something that I think is super important to emphasize with them. Okay, so I have a super quick example for low carbon material procurement, and then I think Rachelle is going to get into some other kind of optimization examples. So an example of a project that my firm worked on was Intuit Dome, huge arena. It was pursuing the LEED LCA credit. This was pre-CalGreen, but we were pursuing the whole building LCA for LEED, and the primary embodied carbon optimization strategy was concrete mix optimization using performance-based concrete specs. And so in our LCA model, we are using in our baseline the NRMCA regional benchmark mixed designs for Pacific Southwest. And in our optimized LCA model, we're using the actual project mixes based on submittals. And we did get on this project, even though it was pre-CalGreen, more than a 10% overall embodied carbon reduction just from that mix optimization because concrete was such a significant contributor to the project's overall embodied carbon. So this one is like a really simple example. The baseline and the design model are pretty much the same. The only difference is the mixed proportions. But as Rachelle will get into in some of the other examples, you can also look at different strategies and combine different strategies. And again, functional equivalence and typical for the project location. This is a great kind of very clear example of that because we can use the NRMCA benchmarks to look at the concrete by strength and by location. And hopefully I understand that when they're publishing the next version of this report, the regions will be a bit more granular. So we'll be able to dig in at a more local level in some of the regions to kind of what's available and what's typical.
I think we might have even been teasing that the last time we gave this presentation.
Okay, cool. Thanks, Laura. Okay, so Luke and Laura kind of went through what is a baseline, how to make reductions from a baseline. There are obviously a multitude of strategies. The table that was it Laura? Yeah, Laura went through. I think Luke made a really great point on like how to. It's so important to establish a framework, and so we'll see that table play out in these structural optimization examples. But first I want to talk about so CLF published this why structural optimization is so important is because a lot of times it's really just coming from reducing material quantities and making material quantity reductions translates almost directly to making like cost reductions. It becomes a lot more cost effective. It depends on what system you're using as well. And we'll get more into that as well. But so yeah, Luke just put the CLF, the latest publication, well, not the late, a publication we did last year called Embodied Carbon Pathways to 2050 for the United States. And through that research, for a lot of different materials, but specifically for concrete, we saw an A1 through A3 emissions reduction potential range of anywhere between 5 to 45%, just due to structural optimization in buildings. And that percentage was about 10 to 35% for steel. And so what that kind of shows is like you can do small strategies and still get small reductions, and you can go out and really optimize your structure and get very significant reductions in your production emissions. Okay, next slide, Luke. Thanks. So this is an example of a building that is constructed in Long Beach. It's a tower. Typical construction for towers tend to be concrete slabs. There are two main types of concrete slabs. There's reinforced concrete slabs and post-tension concrete slabs. The thickness of the slabs is mostly determined by deflection limits, and it takes more concrete volume for a traditional reinforced slab to span the same distance that a post-tension slab can span. So for that reason, reinforced concrete slabs tend to use about 30% more concrete volume than post-tension slabs. And the use of post-tension slabs can be used as an optimization strategy, but it really depends on the type of building that your project is and the location in which it is relevant or irrelevant. For this example, this building to the right and it's constructed in Long Beach, California. It is typical construction practice for a tower project like this to use post-tension slabs for the majority of its above grade slabs. And so it would not be considered an optimization strategy to use PT slabs. And the baseline for this building would have to use PT slabs. They would not be appropriate to compare to a conventional slab. However, this may be appropriate for a wood over podium building, like the building that you see on the right-hand side here. This one is also located in Long Beach. It's a wood over podium project. It has 5 stories of wood sitting on 3 stories of above grade concrete slabs. The podium slab, which you see here marked here, it's a slab that carries all of the wood structure. It's typically recommended to be a typical reinforced concrete slab for a variety of reasons, but one being that it's going to experience a lot of variable loading. There's probably going to be a lot more openings and weird openings on that slab. There's a lot going on, and so it's a lot easier for reinforced concrete slabs to take in that versatility and design considerations than a PT slab that requires the strands to be located in certain locations and extend over certain lengths. A level 1 slab has to be a typical reinforced concrete slab because of shrinkage issues associated with PT slabs and their connection to the basement wall. But the other 2 above grade concrete slabs, they would traditionally be built with reinforced concrete. However, this project specifically optimized the structural system at these 2 levels to be PT slabs and reduced the concrete volume at these 2 levels by 30% and therefore reduced the embodied carbon associated with these slabs by about 25%. And that's an example of an appropriate optimization strategy with the use of PT slabs. This was my baby project when I was on this project a couple of years ago at 843 North Spring Street. It's a great example of where you can just combine strategies from the table this is an excerpt from the table from Laura's table. It's an example of combining different types of strategies to achieve significant reductions. And one of them being alternate material selection, i.e. mass timber. It represented a deviation from typical construction, especially at the time, which was around like 2020, 2021. It also, our alternative material selection gave way to an alternative system selection. And then that alternative system selection was light enough to be able to reuse the existing materials in the design and for a portion of the elements instead of using all new materials. All right, so alternative material selection affected the quantities of the material being used in the building. So rather than using all concrete, which is what could have been this building, and is very it's not unusual to build all concrete for this type of building. Only the podium level and the below grade were comprised of structural concrete. Everything above was either steel framing and CLT, both of which can be lower carbon and are definitely much lighter than a typical concrete slab. And that's very important. So that alternative material selection gave way to an alternative system selection, which again resulted in reduction of quantities in the floor system, and that had cascading effects. Things were lighter, so it had cascading effects for the design of the rest of the building. So it resulted in gravity, lateral, and foundation reductions, and it avoided a wide scale demolition. Had we constructed this building as completely, totally concrete, or even steel framing with a traditional concrete over metal deck, it would have been too heavy for the design to be able to reuse the existing foundations, and so there would have just have to have been a wide scale demolition and excavation, which was avoided. So yeah, we were really able to squeeze every last drop of efficiency in the lateral system, and because the seismic mass was 10% lower than what a traditional building would have been, and that 10% lower not only translated to, we just had 4 bays of brace frames in each direction. It was very light and efficient. And we were able to use the types of braces that were exposed that the architect wanted. If it had been any heavier, we would have not been able to use that lateral system. So the use of the CLT allowed the building to be about 30% lighter than a conventional steel frame building. And the design also was able to reuse existing concrete. The design allowed for about 30% of the concrete in the building to be able to be reused, and like things were enlarged, things were connected. You can see here on the detail that it does require a little bit more detailing effort, and yeah, it just requires a little bit more thought-provoking ways to connect new and existing elements.
Thanks, Rachelle. And so this also a reuse example. So showing that by reusing the element, you're basically offsetting the production of that new material. So you're reducing quantity that way. This was a partial adaptive reuse. So showing that reduction by basically the baseline building would be if you had to rebuild that same building. So sort of similar to the foundation example that Rachelle just shared. And lastly, here we just have a few kind of practical considerations. So I think we've covered kind of the main meat and potatoes of the presentation of like the framework. But there are other considerations that things do not always fit neatly into the boxes, and worth consideration as we go through a project. And the first one of these is kind of thinking about the design, and Lori gave an example of the kind of early design baseline. So there's everyone's been on a project where the building does not stay the same over the course of the project. Either as design is optimized, or say you add floors or reduce floor area, the baseline has to adapt with those changes, right? So the main thing being, what are we doing? What actions are we doing to reduce, and not kind of hiding reductions within kind of variability within the design process. That could also be for like the facade as well. You add kind of facade area. I think one kind of rule of thumb is if you wouldn't count it against yourself, you shouldn't count it for you. Another kind of consideration is just making sure that functional equivalence captures aspects like fire and acoustic, and we'll share a little bit of an example with steel and mass timber. Considerations for transportation, as well as what are the aesthetic finishes, and these are something that are not always clear cut. Something like the aesthetic, you might have a mass timber project that needs to be or is removed finishes because they want to expose the mass timber. Do you get a count? Kind of that removal depends on your scope, depends on kind of what you're considering. First, I think, gave the high level on this design change. If your building changes in function, then you have to update your baseline. In comparing system, I think this is something that comes up quite often, especially for like structural engineers. We're asked to do some optioneering early in design, and it's something that off the cuff, it might be look at these two floor systems and be like, yeah, let's compare mass timber and steel, and kind of on its face looks consistent, but do we consider the topping on the mass timber project to, make sure that it meets vibration criteria? And then we also think, what about fire? Are we meeting the same fire rating for these two designs? So making sure that the scope that we're considering and the recommendations that we're providing are capturing everything, the important pieces that are influencing the embodied carbon and overall design. One other aspect that I see often, and I'll share a tool that I like to use, is here in Southern California we do. I mean, mass timber is exciting and can be a lower embodied carbon option, but we don't have any suppliers here in Southern California. So how that timber gets here is actually a pretty important assumption when we're kind of making recommendations. And we have a project a year or two ago that was kind of looking at this and sharing a tool that John O'Hagan developed, which kind of quickly incorporates, depending on where you are, what that transportation emission is. So worth considering. We found that it took, compared to the A1 through A3 analysis, it was sort of more impactful than you might expect. And then lastly, again, just trying to call out something that is obviously not best practice, but we still occasionally come across studies that use like XPS insulation as a baseline. And anytime it seems like you're sort of cooking the books, we want to just make a case for us as practitioners that we're agreeing that this is not appropriate practice, especially here in California, where this insulation is not allowed. It is prohibited in the state. It should not be used as a baseline.
Yeah, I'll just jump in here, and that was the differentiation between the HFC and the HFO XPS insulation. The HFC blowing agents are what's prohibited here, so you couldn't say, oh, I used XPS with an HFO blowing agent and got this huge reduction, because you wouldn't have been allowed to use the HFC blowing agent in California.
So we trim this presentation down a bit, and we have some other examples if we want to get into them. But ideally, I think it'd be great to kind of open the discussion up, because ultimately, it is the people in this room are completing these analyses and making a case for what is standard practice in the industry. So I'd be keen to open it up, and I have questions for the group. This was something that we proposed, and it's been, a little bit over a year and a half or so. Like, what did we miss? How do you think this should be shared? I'm keen to hear if people have any reactions.
To the point you were talking about just here at the end about the example with the building reuse, and where you're incorporating the modeling of reused materials for that comparison to the baseline. I was just curious if in that comparison you would leave out the reused materials in the updated model. And if you do that, how are you then accounting for like the lower carbon benefit of the reused materials in the LCA? I think it was a couple slides back.
So I think there's some difference between if the materials that are purchased are reused, or if you're reusing the building itself. If for example, like the foundations or in this project, where some of a good portion of the structure and the existing structure and facade were reused, basically built the baseline as if you were building that portion again, using current materials. Like what would it have been if you weren't using those reused materials? In this case, adaptive reuse and not salvaged. If you were using like salvaged materials, I think there's the approach would be more along the lines of omitting those manufacturing emissions.
Yeah, I want to add to that because we did the same for the 843 North Spring Street project. But it was adaptive reuse. So we were like the foundations were a certain size and we had to enlarge them due to the larger forces that were imposed on them, like for that example. So the existing concrete volume of the existing foundations was not considered in the actual design model. But yeah, we use like the same concrete mix that we use to like enlarge in the foundations as in the baseline model. But I think like a really good example of that of the difference between that and like salvage reuse materials is like the City of Boulder's hospital project, where they deconstructed deconstructed the hospital. They salvaged, I think, like 120 steel elements, steel beams. And so like the A1 emissions associated with those steel beams are not necessarily don't have to be considered in the new buildings that will be using those salvage materials, but there are like A2 and small A2 and A3 emissions that were required to be like refabricated for the use in the new building, and so that should be accounted for in the when you are using reuse or salvage materials. Oh, also, wait, I'll put a link to this. AISC just came out with a new EPDs, like steel EPDs, and one of them is specifically just to calculate fabrication. So I'll put a link to that in the chat, but it's like really freaking cool. So yeah.
Very cool. I think I saw Sharky was here. Sharky, I just wanted to plug our LCA user group.
Yes, let me do that. There's a meeting on Thursday. Oh, wait, sorry, next Thursday, the 5th. That'll be the first one of the year.
Yeah, great. And so we've partnered up with CLF Seattle. Is the Boston group also involved with that, Sharky?
The Boston group is not involved right now. There's talk of maybe some collaboration later in the year, but at the moment they were happy to keep their own thing running along.
Nice. That's another group to continue to have discussions like this. Yeah, go for it, Victoria.
I am curious about if you are not the structural engineer, how feasible have you found to get an archetype or a baseline where it's a typical construction versus utilizing your design and just doing kind of like the procurement industry averages versus what was installed for the final as-built quantities and products. Did I worded that right?
I think
My
I
question
got what
is,
you're
okay.
I think I got what you're asking. You're asking like
Okay.
if you're using an alternative structural system and you wanted to use like the building archetype approach, but you need material quantities for that
And you don't
archetype to
have
compare.
a
Yeah.
structural
Yeah.
engineer on your side to do that because it's not in their scope and they don't have the time to do it.
Yeah, I don't know, address that. I think if you don't have the structural engineer on board, you're probably gonna have a pretty hard time getting them to design it. Ultimately, too. I think it's something we can communicate early on and make a case for with the client. But the client would probably have to direct the structural engineer to do those studies.
Yes,
And
most of the time it is not part of their scope of work, which has been contracted before we have a conversation with the team, with the design team. And therefore, sometimes even the conversations do not include the client, or the client just needs to comply with a requirement and they do not care how is it done. They want you to meet the requirement. So just having that, like how do you all tackle the baseline when you cannot do it the way that you're proposing here? I mean, with the examples, the case studies that you were showing, most of the cases you all were the structural engineer and you were able to run the calculation.
Yeah, I think you're limited to more procurement options, which sadly I to say is not uncommon, but it does kind of tie your hands a bit.
And I think like ultimately what we're all trying to do here, what CalGreen is trying to do is to get us to do better than whatever business as usual is. And there's kind of the separate issues of what did I actually do that was better? And then what was I able to document in my LCA? Because in some cases there might be some stuff that you did that you are pretty sure is a good thing. Um, but if you can't document the baseline properly, you might not be able to document that in the LCA. But ultimately, we just want to make sure that we're like trending in the right direction and not kind of using the manipulating the baseline to like tell a story that maybe doesn't really reflect what we're doing. We want to get real reductions.
Yeah, tell a story that just checks the box that you meet
Yeah.
the CALGreen performance requirement.
I think
Yeah.
also, I just want to add, I think this also just points to how important it is to like have these discussions early on, like Luke said, and so the structural engineer can have this in their scope. Like there's no reason why it can't be a line item in their scope. And usually the design fee is like insignificant compared to the actual like material quantity reductions that the cost savings that the client will see. So I think it's like, and I know I'm saying this like as if it's like super easy to wave a wand. Like I struggled with that a lot when I was a practicing structural engineer because I don't think a lot of clients like saw that value in it. But I think that also as policies become more stringent, like you're gonna need to engage the structural engineer, and like the policies may force the client to spend a little bit more on their design fee in order to like meet requirements and also save costs like from material quantities. Yeah.
I do want to share a couple resources that I'm excited to have recently tried on projects. Oh, and sorry, Selena, I just saw you raise your hand, so I'll quickly just share these. But with the benchmark tool, I think we have some better case to show like how our buildings are performing relative to other projects. So this is a nice place to show you can map out for a client like, oh, we're doing, hope either very well, good, or poorly sometimes, and try to influence that way. And the other one that I we'll see how this plays out in the near future for me, but I did push back against some structural design that was very heavy, and so as part of this benchmark study, CLF has also made public the material use intensity. And so we can also kind of show, your mass of your building is inefficient relative to a large population of buildings, and that there is some cost considerations for that, which sometimes is more convincing. But yeah, just share those couple resources. I'll drop in the chat too, but those are at our disposal, and I'll hand it to you, Selena, with your hand up.
I just want to add to the prior discussion that sometimes it is hard to get the buy-in from the client. But when you're selecting your team, if your structural engineer is part of the 2050 commitment, then you can have those conversations internally, especially if the architectural firm is part of the A.I.A 2030, and you do what I call sneaking the broccoli in the smoothie. Like as long as you're not significantly affecting cost, schedule, you do as much as you can, but you might have control on selecting a structural engineer that has that as an internal goal for the firm.
You got to sneak that broccoli in. Yeah.
And when you're probably comparing options for cost relatively early on in the project, so you can also compare those options for embodied carbon.
Yeah.
One benefit to, or doing a good thing that I feel like doesn't get captured, I'm keen to float it out there to the group, is around specific for structural engineers. We spend so much time on lateral design and resilience, and it's something that doesn't show up at all in our life cycle assessment. So I have a project that recently is pursuing isolation and to improve the long-term resilience. And it's something that I think would be interesting as a community to also address kind of how could we capture that? Is there some way of, looking at the performance of the project over the expected lifetime, our 65-year, 60-year, what our LCA scope is, and have like an expected damage, or take some of that data that then could, also be translated to the benefit for embodied carbon, which is expected from a better design. So I don't know if that's really a question, but that a gap, and there also is no real standard for capturing those design aspects. Rachelle, I forgot to plug the alternative means and methods for CALGreen. That's something we said we wanted to talk about. It's something that is under consideration. So many folks may know that with the latest round of code updates, that we've sort of been put on hold because of fire rebuild efforts. There aren't going to be major changes to the building code this year. But when we were originally, trying to work with A.I.A. to incorporate some of this new benchmarking study into carbon CUR, carbon use intensity, like embodied carbon equivalent of EUI, we did establish some thresholds for performance, and so it has been proposed as an alternate means of percent reduction, that those performance targets be met for a few very common project typologies. I don't know if Laura or Rachelle, anything you'd add to that, but that's sort of the gist.
Yeah. Did you sorry, did you clarify what the alternative means is? Like basically it's embodied carbon budgets?
It's carbon use intensity, so it'd be like your kilograms per meter squared.
Yeah, okay.
I don't think I explicitly said kilograms per meter squared, but
Okay, no, I was just yeah, okay. Oh, one thing I wanted to add is so the article where A.I.A is talking about this, A.I.A California, I just added the link in the chat, but they are seeking interested organizations to share like in the cost of the development and support of this package. So they are calling for like if you're an architect interested in using the embodied carbon budget compliance approach to the CalGreen embodied carbon mandatory measures via this process, this alternative means and methods process, then please let them know. You can send any notes of interest to Sarah Vasquez, and I'll put her email in the chat as well. That's all I want to add.
Yeah, and that article has a little bit more information about how the alternative means and methods request works for anyone who has not done that before.
I do also want to plug a couple upcoming events. The first of which in 2 weeks, I see lots of familiar names in our participant list. Folks I know already be going there, but if you haven't seen, CIOSC is putting together a sustainability summit. It's going to be at Caltech. Also a really great lineup of speakers, and going to be lots of great content. And so link to that's in 2 weeks. And then I'll also plug for any SE 2050 folks that we're going to have our summit again this year. It's going to be alongside the Structures Congress conference in Boston. So registration for that is open for another month and a week. Would be great to see folks there.
I will plug if there is anyone on this call who has ideas for an event that they would like the CLF-LA Hub to do, or speakers they would love to hear from, or if you have a lovely office space that you would like to host an in-person event for our hub in, please reach out to us, because we're always looking to work with broader groups of people to put these events together.
Yep, and we got lots of fun stuff planned for the year, and just a real big thanks for everyone taking the time to join and listen and hopefully learn a little bit something, and we really appreciate it and really appreciate this community. Well, we'll see you at the next one.
Thank you.
Thanks, everybody.
Okay.
Thanks.
Thanks.
Thanks.